Hi all, this is Abhay Mahajan and I welcome you all to this amazing series called INMO Question of the Day. The question of the day for today's lecture is this. This is a very good geometry question and let us see if you're able to do this without any hint or using the hint, or if not at all, you will be able to take something out of it, right? So it's a beautiful question of mathematics. The question says an acute angle triangle ABC has orthocenter H. The circle passes through H with center the midpoint of BC, intersects the line BC at A1 and A2. So circle passing through H with center the midpoint of BC, intersects the line BC at A1 and A2. Similarly, the circle passing through H with center the midpoint of CA intersects the line CA at B1 and B2. And likewise, the circle passing through H with center the midpoints of AB, midpoint of AB, it should be midpoint of AB intersects the line AB at C1 and C2. Show that A1, A2, B1, B2, C1, C2 are concyclic, or they lie on a circle. So before I give you a hint, I would request each and every one of you to draw the diagram on your own, because if you draw the diagram on your own, you'll get certain hints. So you can pause this video and draw the diagram on your own, and then you can unpause, and then I'll give you the hint in the next moment. So if you've drawn the diagram, guys, diagram looks something like this. Diagram looks something like this. So ABC is a triangle. It seems to be an acute angle triangle. H is the orthocenter. So we have this a 90 degree. This is 90 degree, and this likewise is 90 degree. Okay, right. So the point of intersection is H. So a circle drawn with midpoint BC and passing through H. So circle passing through H and midpoint BC. So I've named midpoint of BC as MA. So this is the point of, this is the point of intersection of the median and the line BC. So midpoint of A, and circle drawn through with center as midpoint of A with and passing through H. It intersects these two, BC at A1 and A2. Likewise, circle pass with center at MB and passing through H intersects line AC at B1 and B2, and circle with the center MC and passing through H intersects the line AB at C1 and C2. We need to prove A1, A2, B1, B2, C1, C2 lie on a circle. तो बच्चों इस तरह के क्वेश्चंस के अंदर एक बहुत सिंपल सा लॉजिक होता है. अगर हम किसी भी तरीके से एक ऐसा पॉइंट फाइंड कर लें जिसका डिस्टेंस, उस पॉइंट का डिस्टेंस A1 से एंड A2 से एंड B1 से एंड B2 से एंड C1 से एंड C2 से सेम है मतलब इट इज इंडिपेंडेंट ऑफ ऑल दी एनी एंगल. अगर एंगल इन्वॉल्व है तो तीनों के तीनों कंबाइंड एंगल्स इन्वॉल्व हैं, राइट. सो अगर वो सिमेट्रिकल रिलेशन आ जाता है उस पॉइंट से A1 का या A2 का या B1 का, B2 का, C1, C2 का, एंड देन वी आर डन. सो यू नीड टू आइडेंटिफाई दैट पॉइंट. कौन सा पॉइंट हो सकता है? और अगर हम ट्राइंगल की बात करें, ऑर्थो सेंटर ऑलरेडी दिया हुआ है, ठीक है, और कौन कौन से पॉइंट्स बचते हैं? सो वन इज इन सेंटर, वन इज सेंट्रॉइड, एंड द थर्ड वन इज द सर्कम सेंटर. ठीक है, सर्कम सेंटर, सेंट्रॉइड, इन सेंटर, ये तीन पॉइंट्स बचते हैं बिकॉज ऑर्थो सेंटर तो ऑलरेडी दिया हुआ है. तो अगर मैं किसी तरीके से इन्वॉल्व होके ये निकाल लूं कि क्या इन तीनों में से कोई पॉइंट है, अगर है, एंड ये प्रूव कर दूं कि उस पॉइंट का A1 से डिस्टेंस इज इंडिपेंडेंट ऑफ एनी स्पेसिफिक एंगल और इन जनरल सिमेट्री आ रही है, देन वी आर डन, राइट. द हिंट, now I'm going to give you a hint. You can all pause the video if you do not want to listen to this hint, and those who want to listen to this, the hint is, so there are several hints. So hint one is, so since orthocenter is involved, we should know that AH is 2R cos A. So this is what we know. AH is 2R cos A. And also अगर हम इसके सर्कम सेंटर की बात करें, वजह सर्कम सेंटर की बात करें, तो सर्कम सेंटर इज नथिंग बट द पॉइंट ऑफ इंटरसेक्शन ऑफ द परपेंडिकुलर बाइसेक्टर्स. तो यहां से परपेंडिकुलर बाइसेक्टर, यहां से परपेंडिकुलर बाइसेक्टर, इफ इट इज मीटिंग एट हियर ओ पॉइंट. सो मुझे पता है OMA इज R cos A. सो जब भी ऑर्थो सेंटर इन्वॉल्व होता है, सर्कम सेंटर से बहुत काफी क्लोज वाला रिश्ता होता है. सो AH is 2R cos A and OMA, it doesn't seem to be, but अगर AH इतना है तो O यहां पर होगा कहीं, राइट. So OMA is R cos A. So OMA is half of AH. Okay. So one is this hint. You can use these hints. Also since this is also 90 degree and this is also 90 degrees AH, so this altitude and this perpendicular bisector are parallel to each other, and this is R cos A, this is 2R cos A. तो अगर इसका midpoint अगर मैं mark कर लूँ किसी तरीके से, let's say I mark this as A double dash, A double dash. So can I say A double dash H and O say MA are equal? A double dash H, midpoint, where A double dash is midpoint of AH. A double dash is midpoint of AH. A double dash is midpoint of AH. Since AH was 2R cos A, so A double dash H will be R cos A and OMA is also R cos A, and these two are parallel. So can I say I can sense that A double dash H, MA and O, they form a parallelogram. We can use this fact, right? We can use this fact also. So if I draw this, so this will be a parallelogram. I can use this fact as well. Now, what else? Also, A double dash MAO. A double dash MA and O. This will also be a parallelogram. This will also be a parallelogram because A double dash is R cos A and OMA is also R cos A. So A double dash MA and O will also be a parallelogram. A double dash MAO will also be a parallelogram, right? And we also should know that sum of the squares of the diagonals in a parallelogram, so this is A, this is B, this of course will be A, this of course will be B, and let's say the length of the diagonal is D1 and length of the diagonal here is D2. So can I say D1 square plus D2 square is equal to A square plus A square plus B square plus B square. So 2 times A square plus B square. So this is one result which you should know. So in a parallelogram, the sum of the squares of the diagonal is twice the sum of the squares of the adjacent sides, or the sum of the squares of all the sides. So this is one thing that you can use. So these are the certain hints, right? So you can pause this video again, use these hints and try to prove if O is indeed the center of the circle which contains the points A1, A2, B1, B2, C1, C2. किसी तरीके से prove करो बच्चे कि O is the center of that circle, right? वो किस तरह से prove करेंगे? अगर मैं किसी तरह से prove कर दूं that OA1 हमेशा constant है और it is independent of all the angles, or if this result is a symmetric result, I think we're done, right? So this is the hint. You can pause this video now. You can try on your own and see. And the next moment, I'll be giving you the solution. So these are the certain hints that you can apply, right? Chaliye. Let us move on. Let us enlarge the diagram. Okay, so what we have. So we'll be making use of those hints in this particular problem. So we know that AH, let me write some specific things. AH is 2R cos A. And since this is the midpoint, so यहाँ पर A, अगर this point is O, so we know that OMA is R cos A. OMA is R cos A, and if I put or use or mark this point as A double dash or A dash, then we know that A double dash is equal to A double dash H is also R cos A. And since this is 90 degree and this is also 90 degree, so we have two more things. One is A double dash, A double dash, MAO. MAO is a parallelogram. Likewise, A double dash, or likewise A double dash HMAO. A double dash HMAO is also a parallelogram. A double dash HMAO, because these two lengths are equal and these two lines are parallel, so they will form a parallelogram. Likewise, A double dash and OMA, they are equal in length, and they will also form a parallelogram because these two are also lines which are parallel to each other, right? Now, if I somehow try to prove OA1 is independent or is very symmetric, then I will be able to prove that O is the center of the circle which contains the points A1, A2, B1, B2, C1 and C2. That is it. So OA1 square, we'll be using the Pythagoras. So OA1 square is equal to OMA square plus MA A1 square. MA A1 square, and we know that MA A1 is same as MAH. MA A1, because MA is the center of the circle which contains H and A1. So we have OMA square plus MA A1. Can I write MA A1 as MAH whole square? MAH whole square. So now what do we have? Now we can see that H, MA, O and A double dash, they form a parallelogram, which we've already proved. So since O, A double dash, H and MA form a parallelogram, and OMA and MAH are the two adjacent sides. So can I write that this is equal to half of the sum of the squares of the diagonals, which is MA A double dash whole square plus OH whole square. Now for a triangle, O and H are fixed points. So OH we need not worry about. We need to see if this can be written in general terms, because यहाँ पर A and A double dash are involved. तो अगर हम इसको किसी तरीके से simplify कर दें and लिख दें, I think we're done. Also we know that MAA double dash, MAA double dash, MAA double dash. So this is also parallelogram. So we have one more parallelogram. So this is also a parallelogram, A double dash, MA and O and A. ये parallelogram कैसे हैं? Because we know that A double dash and OMA are parallel and equal in length. Both of these lengths are R cos A. So MAA double dash is same as AO. MAA double dash is same as OA, and we are done, because this can be written as OA whole square plus OH whole square, and OA is nothing but capital R. OA is nothing but capital R. So we have proved that OA1 square is half times R square, which is the radius of the triangle, plus OH square. That means the distance between the circumcenter and orthocenter, which for a triangle is obviously fixed. So can I also prove likewise OA2 square will be same, and OB1 square and OB2 square will be same, and OC1 square and OC2 square is also the same, and that means O is one such point which is equidistant from A1, A2, B1, B2, C1, C2. So that means all these points lie on a circle whose center is O, which is actually the circumcenter of the original triangle also. And we are done. Right. I hope you've all understood this problem, and I give you hints. And if you don't know any 1, 2 or 3 specific points of those hints, you can always Google up and see the notes which we've also shared in the INMO booklet that we have shared with you, and the booklet is free of cost. I hope you've enjoyed the solution. Take care.